Hi and welcome back to the next session. Today we are minimizing the costs under Solver. Here we have a transportation problem here, and we want to minimize the costs of transporting goods from production plants to warehouses near metropolitan demand centers, while not exceeding the supply available from each plant and meeting the demand from each metropolitan area. So what we have here are the plants, as you can see, Namave, Mbarara, Nakawa. The total number to be shipped by each warehouse is 5 shipments. The number to ship from plant X to plant Y, that is from Mukono, Jinja, Kayunga, like each plant has to supply to 5 warehouses, has to ship to 5 warehouses. Yeah, that's why in total we have 5. Then each warehouse receives from 3 plants. Each warehouse receives 3 shipments. Yeah. So this is the demand by the warehouse, yeah, as you can see. Then down here we have the shipping costs from plant X to plant Y. We have an unstructured problem here, and we are just assuming at the first stage. So given this kind of problem here, given this kind of costs incurred here, we want to make sure that we minimize them while meeting the demand of the warehouses and not exceeding our supply. Okay, so these are the total costs. Here we just had to sum up here, then here, then here, then here, then here. Then supply at plant, this is what it is, like it shouldn't exceed this. It is the maximum each plant can supply, but this is the demand by the various warehouses. So what we have to do is to minimize these costs as we make sure we don't exceed our supply, but meet the demands of the various warehouses. So what we are seeing here, the problem presented in this model involves the shipment of goods from 3 plants to 5 regional warehouses. Goods can be shipped from any plant to any warehouse, but it obviously costs more to ship goods over long distances than short distances. The problem is to determine the amounts to ship from each plant to each warehouse. Yeah, so the amounts to ship, in this case, as we say, the decision variables, they can be in form of numbers, levels, quantities. So we have to determine the amount to ship to each warehouse. At first we are assuming 1 shipment. Yeah, we are assuming 1, but we want Solver to determine for us what can we ship while minimizing the costs. So that's why they are saying the problem is to determine the amounts to ship from each plant to each warehouse at minimum shipping costs in order to meet the regional demand while not exceeding the plant supplies. Okay, so when we move here, let's try. Remember, in Excel we start by model formulation, then we determine the objective function. So let's go to Excel so that we can formulate our model. Okay, so we go back to our folder. Last time we created a folder, so we can call this minimization, the new text sheet, minimization, minimizing costs. Let's call it minimizing costs. Then we can go ahead and double click on it to open it. Then we bring our Excel file here. Then we can name this as transportation problem model, Margin Center, then transportation problem model stroke prototype. So we formulate a model here. Oh, what have I copied? My God. So you go back, you copy the red model. Since these ones I already formulated them, yeah, I'll just copy and paste. So I copy everything up to here. I copy. Then paste. So upon pasting, remember these are not automatically there, so you first have to delete them so that you see where I got them from. These ones, they were not meant to be there. We are only assuming this number of to ship, plus also the demand by the warehouse, and also this is the maximum we can supply at this kind of costs. So each plant has to make 5 shipments, so you click sum because it is supplying to 5 warehouses. So you sum and then you can autofill for all the plants. Then each warehouse receives from 3 plants. So we sum equals sum, enter. We are formulating a model. Then when you come to the costs, these are the costs assumed. They are in dollars. Okay. So the costs are here, sum, then you copy, and you can autofill. Remember these are dollars. So after autofilling, we need to know the total. Remember this is the cost per warehouse, the costs incurred per warehouse. These are the costs incurred during shipment. Yeah, these are incurred by Namamve, these are incurred by Mbarara, these are incurred by Nakawa, but all through the various warehouses. Just as we say, this is linear programming. You have to linearly position the number to ship with their relevant costs. Okay, so what we do here, we get a total sum. Since we are minimizing costs, we need to determine the objective function after model formulation. We've formulated a model that has the numbers to ship, which represent the decision variables. We have the constraints here. So we have constraints here. Also, these are constraints. So these are the specific costs to the specific warehouses. I need to determine the objective function, so I'll say equals sum enter. Lol, why is it bringing this? Okay, equals sum sure, as if I saw an 83 here. What did I miss out? What did I miss out? Hey, okay. This had to be up to here. Oh, what is this? Anyway, I think let me just delete and calculate again. Okay, so we need to get some here, this and that. Okay, so we repeat again and we sum the costs. Enter. So all these are dollars. I'm sorry about that. I had made some simple error, but all is well. So let's insert the dollar at this 0 decimal places. It has to be US dollars. Then you click OK. So this is our objective function. We are aiming at minimizing costs. So after formulating a model and determining the objective function, there we can go ahead and solve. You go to Data tab, Solver. Data tab, Solver. This time round, the set objective is the costs. And we are minimizing costs. So by changing cells, the decision variables, they are the ones to change. Just like we said that decision variables represent number, amounts, levels of production. So they are always the changing variables. Then you start adding your constraints. In our question, let's see the constraints. So constraint number 1 is total number shipped my good. Okay, so the total constraint says total number shipped must be less than or equal to supply at plant. So you come here. Where is the total number shipped? Total number shipped is somewhere. Oh, let me first delete things. So that we can see clearly. So let's go back to our solver. Our objective function is this. We are minimizing. The changing variables are the number to ship, the decision variables. Because at this point you can determine how many shipments to make to what warehouse. Then add, they are saying total number shipped must be, let's check again, must be less than or equal to supply at plant. Total number shipped is this, must be less than or equal to supply at plant. So the supply at plant is this. Then you add a constraint. They are saying total shipped, let's try to cross down. Total shipped to warehouse must be greater than or equal to demand at warehouse. Let's see. Total shipped must be greater than or equal to demand at warehouse. So the total shipped here must be greater than or equal to demand at